All right, welcome back to this session. We had a bit of a network glitch. So going back to what we've done here, we've calculated the grand mean for male. There are 5 males here. The grand mean is 2.68. The standard deviation is 0.60. And then for female, 5 respondents, the mean is 3.34 and the standard deviation is 0.61. Now let's go back to our question. Our question says, calculate the grand mean and standard deviation of a student's academic adjustment scores for male and female. So this is what we need. All right. So we've gotten the grand mean and the standard deviation for male and female group. Now the next thing we are going to do is this table we have here is not really in the format that we want. This is a table that SPSS provided. And if you look at our format or the formats in which we should present it, they want it to be in this format where you have one of the categories in one side in 2 columns here, and then the other category in this column. So we are going to handwrite that. So we are going to have something like this. All right, so this is what they want us to get. So for the mean and standard deviation, we are going to present our table in this format. So we are done with, having done this, we are done with D. The next section, and so to explain this first table, we can say that the mean, the grand mean for male students is 2.68, while the standard deviation is 0.60. The female grand mean is 3.34 with the standard deviation of 0.61. So this implies that the female had a higher mean than the male. So this implies that females have a better adjustment than male students. All right, so the next thing we are going to do is we're going to conduct the independent sample t-test to determine if this difference is significant or not. So you can see that there's a difference here. All right, so we see that there's a difference here. So what is the difference? We are going to subtract 3.24 minus 2.68. So there's a difference of 0. Am I right? Yes. The difference of 0.66. So this minus this is 0.66. Now let us find out if that difference is significant or not. So I would liken independent sample t-test. So the independent sample t-test is to test for our hypothesis, okay? So what we have done here, we've just answered the research question. We've gotten the mean rating, okay? So the next thing we are doing is to test the hypothesis. So I would liken independent t-test to a story of a young chap that was caught, that was, people said, people were accusing of that he stole something. So the research question in this case would be, did he steal the thing he's been accused or not? That's a research question, all right? So research question is very straightforward. It just requires a simple response. Now, if we go further to do hypothesis testing, our hypothesis can be if he stole, okay, we're going to use a null hypothesis. We're going to assume that he didn't steal. All right. Now, if based on our findings will tell us if he stole or if he did not steal, but that's not where we are going to. We are going to the stealing, is it significant or not? Like, is it something that is something that is significant that the person has to pay for it, or we can just overlook it. So for independent sample t-test, we focus on if that difference is something that is very large, okay? So that's what we want to do now. And let's not forget, we will need this information to carry out our independent sample t-test. So I'll just place it here for the main time. Now, to do our independent sample t-test, remember we have this in mind. Go back to your data, go to analyze, go to compare means, go to summary independent sample t-test. Now here is where you are going to type the number of cases. You can see we have sample one, we have sample two. So our sample one is male, all right, male undergraduates, and sample two is female. Now what is the number of cases? Number of cases is the number of students that responded from the male angle and for female respectively. So we go over here, we have 5 males. What is their mean score? We come over here, their mean score is 2.68. We copy, we paste it here. Oh, it's not pasting. Okay, let me copy from our actual work. Okay, so we are going to paste this here. I hope it's going to paste. Okay, so we go over here, we get our standard deviation score for male students. We copy it, we go over here, and then we paste it here. Now the label, what's the label? It's male students, all right? So we're going to do the same thing for the female students. Over here, we have 5 female responses, and the mean we have for female, the mean for female is 3.34. So we are going to copy this, right click, click on copy, go over here, right click, and then we paste. And then the standard deviation is 0.61 for female. And here we have our label. Our label is going to be female. All right, then click on your OK button, and you're going to get your independent sample t-test results. So we are going to give it a bit of time. You can see from this indication here that it is running. So it probably take a few seconds to be able to provide us the results, the table for our independent sample t-test. So it's very important that we realize that the mean and standard deviation that we get from the two groups is what we are going to use to carry out our independent sample t-test. Now we are going to go back to see our results. So yes, we have our results now. We have our results now. And you can see that this is what we are interested in. So copy it, copy your results, go over here, copy your results, go over here and paste it. So this is my result for this independent sample test. Now, the question here says, present the results of the descriptive and inferential statistics in appropriate statistical table. So we can see that from our sample, from the sample question. So this is how our independent sample t-test table is going to look like. All right, so I will just copy this format, and then I will go over to my question. I'll fix it here. So Okay, so going back, this will be 5. This will be 5. This is 2.6. 2.68. This is 0.60. This is 0.61, and then this is 3.34. Okay, so what is our degree of freedom? We're going to see it. DF means degree of freedom. So we're going to see that from our table here. So our DF here, DF is the total number, the total sample size, which is 10 respondents altogether, minus 2. That is our DF. So our DF is 8. So we come over here and we impute 8. And then our T value and our P value, I'm going to explain this because this is what's going to tell us if our hypothesis is correct or not. So going back to our results, what is our T? Our T is minus 1.725. So this is minus 1.73 approximately. What is our p-value? Our p-value is the same thing as sig 2 til. All right, so this is our p-value. You can see we are only using this first row. All right, we are assuming that there are equal variances. So this is our df, this is our p-value or significance 2 til. So our p-value is 0.123. So we are going to come over here 0.123. Now, for remark, this is the rule we are going to use. If my p-value is greater than 0.05, what am I going to do? I'm going to accept the hypothesis that I have stated. It means that the hypothesis is true. But if my p-value is less than 0.05, I'm going to reject the p-value that I have stated. All right, so how do we compare that? How do we compare that so we know if we're going to reject or we're going to accept? This value, is this value greater than 0.05 or is it less? You can see that it is greater than it. And from our first statement here, we say if our p-value is greater than 0.05, we are going to accept our null hypothesis. Our null hypothesis says that there is no significant difference, all right? So if it is greater or if it is equal, we are going to accept our null hypothesis. Now, you can see that our p-value here is bigger than 0.05, okay? So it means that the hypothesis, the guess that we made is actually true. So what we are going to do here is that we are going to say what? We are going to accept our null hypothesis. We're going to accept our null hypothesis. So we can see that the table for our p-value. So yes, we are going to also state this because it's not enough for you to say that you accept or you reject. You have to, so we accepted. Why did we accept? We accepted because our p-value is actually greater than 0.05. All right. Now the next one. Okay. What we've just done now is H. It says test the null hypothesis using the 0.05 level of significance and state whether the null hypothesis should be rejected or retained. So we have done this. And the G says answer the research questions based on the results obtained. Our research question that we created was that what is the mean rating? So the mean rating, now to answer our research question, the mean rating for male was 2.68 with standard deviation of 0.60, while that for female is 3.34 with standard deviation of 6.61. So if you've done to this up to this point, you are done with question number 1. Now, finally, we're going to answer our number 2 question. Number 2 is very straightforward because the PPMC table, for PPMC is not like question 1 where you need 2 tables, the first table to answer your research question and the other table to test your hypothesis. The PPMC is very, very straightforward. It gives you just 1 table, and from that table, you can be able to answer your research question and also test your null hypothesis. Now, the question here says, using the same data set provided, investigate the relationship between students' CGPA and their academic achievements. Now it now says develop one research question that can be answered using the PPMC. All right, so let's go back to our sample format. So our sample format gives us an idea about how we can develop our research question. All right, so for research question for PPMC is very straightforward. We are just going to say what is the relationship. Is there a relationship between the first variable and the second variable, all right? So we are going to develop our research question. So what is the relationship between, what are we looking at? Student CGPA. All right, so I'm going to replace this. Is there a relationship between student CGPA and what? And their academic achievements in public universities in Nigeria or in senior secondary schools, whatever you want to use. So we are done with the research question. The next thing we want to do is to answer the next question. The next question is B. B says, formulate the corresponding null hypothesis. So remember, we are working with students' CGPA and academic achievement. So the next phase, I'll just paste this. So our null hypothesis is going to be, there is no significant relationship between student CGPA and academic achievement in public universities in Rivers State. Or we are going to say student CGPA does not significantly relate to academic achievement in public universities in Rivers State. So if you've done this, you've got your results. Now the next thing we are going to look at, number C says using SPSS, compute the Pearson product moment correlation between CGPA and academic achievement score. All right, compute. So remember we are looking at CGPA and academic achievement. So we'll go back to our table, analyze, correlate, bivariate. We're going to move our CGPA and academic achievement into this box. Oh, we don't even have academic achievement. Okay. We're going to create that quickly. We're supposed to have academic achievement score. I don't know why that's not the case. So we're going to create that quickly. Remember, we are not working with the individual responses. We are summing up the responses. And for PPMC, you are always using two variables that are cumulative, all right? The data provided for the responses are cumulative. So we want to call this academic achievement. Remember, when you're typing target variable, you don't have to create any form of space there, otherwise it's going to be rejected. Okay, so we're going to go back to our PPMC. So we're going to go to analyze, correlate, bivariate. We want to move CGPA here inside the variable box and this, and then we click on OK, we are done. We've gotten our results. So this is the result that we need. So I'm going to come over to this. It says using SPSS compute the PPMC Pearson product moment correlation R between CGPA and academic achievement score. So this is what we have gotten for that. Now the next question says determine whether the correlation is statistically significant at 0.05 level of significance. Now we are going to follow the example that we have. So in our format here, you can see that this is the range we have. If the arrow value, if the Pearson product moment correlation arrow value is 0, it means that there is no relationship between the two variables. If it is within this range, it means that there's a very low relationship. If it is between this range, there's a low relationship. If it is within this range, there's a moderate relationship. If it is within this range, there's a high relationship. If it is within this range, there's a very high relationship. And finally, if it is exactly 1, it's a perfect relationship. So I'm just going to copy this so that we can have it visible. All right, so we are going to have it visible. Okay, so we've gone through so going over here now, I'm just going to paste this somewhere where I can easily visualize it. Okay, so where is our Pearson correlation value? Now look at it. Pearson correlation, look at the value. The value is 0.970. Now, what range does 0.970 fall within here? You can see that it is at very high relationship. All right. So it's at a very high relationship because 0.970 is within this range of very high relationship. So depending on the range where your value falls under, whatever value you have here will determine which one you're going to select. So it says present your result in an appropriate statistical table. So this is a table. This is how it's supposed to look like. Now it says answer the research question based on the results. So my answer for my research question is that there is a very high relationship between students' CGPA and academic achievement in public universities in Rivers State. So we've been able to answer that research question. All right. So our answer to our research question is that there is a very high relationship between students' CGPA and their academic achievement in public universities. Okay. Now the next thing we're going to do, we're going to test the null hypothesis, just like we did in the previous mean standard deviation and independent sample t-test. So we assumed that there is no significant relationship based on our hypothesis. We said that student CGPA will not significantly relate to academic achievement in public universities. That's one way to state it. Another way to state it is that there is no significant relationship between student CGPA and the academic achievement in public universities. Now let us see if that is true or not. We are going to borrow a leaf from what we have done here. All right, we're going to borrow a leaf from what we have done here. If our p-value or our sig two-tail is greater, I'll just write it down here so it will be easier for me to work with. Okay, so we are going to, we have answered our research question. Now we want to test our hypothesis. Now, where is our p-value? Now, looking at this table, I've shown you where our arrow value is. Our R value is 0.970. Now, where is our p-value is this sig2 tail. You can look at this and trace it down here. So from what we have here, our sig2 tail or our p-value is 0.00. All right. Our p-value is equal to 0.00. Now, remember we said that our p-value or sig, our p-value or sig 2 tail is equal to 0.00. Now we follow the rule. Our rule is that if the p-value or sig 2 tail is greater or equal to 0.05, we are going to accept the null hypothesis which we have stated. But if it is not, we are going to reject it. Now our p-value is 0.00. What are we going to do? Clearly, it is way less than 0.05. Okay, our p-value is 0.0. So 0.00 is actually less than 0.05. So it means that we are going to reject our hypothesis. We are going to reject our hypothesis. So the answer to our hypothesis question, it says test the null hypothesis and state whether it should be rejected or retained. It will be rejected because the p-value we obtained from our table is 0.00, and based on our rule, if p-value or sig value is greater than 0.05, we are supposed to accept the hypothesis, the null hypothesis. But if it is less than 0.05, we are supposed to reject it, and actually it is less than 0.05. So we are going to reject our null hypothesis that we have stated, that students' CGPA will not significantly relate to their academic achievement. So we are going to reject that hypothesis. So it means that we are going to accept our alternate hypothesis, which states that the student CGPA significantly relate to their academic achievement. Now, the final one is we have to interpret the strength, the direction, and the significance of each of the relationship. All right? We have to. Now, I will need this information I have here to answer the final question. Okay. So they said interpret the strength, the direction, and the significance of each of the relationship. So what is the strength? The strength is very high. There's a very high relationship between students' GPA and their academic achievement. That's the strength. And what is the direction? Direction, is it positive or is it negative? It's a positive. It's a positive, is a high relationship in a positive direction. So what it means is that an increase in students' CGPA scores will bring about an corresponding increase in their academic adjustment. Okay. So and then it said, and the significance of each of the relationship. The significance is that an increase, a very high increase in the student CGPA is going to result in a very high increase in the student's academic adjustment. Okay, so that is where we are going to wrap this up. Thank you.